This is the video on constructing explanations for your claims, evidence, and reasoning. Best thing you can do right now is go ahead and open up your guided notes. They're from 919, and I'll show you exactly what they look like. So our learning targets for today are to explain results based on evidence, apply scientific ideas and principles, to explain any evidence, and use evidence to defend and evaluate claims. So this is something you will always use throughout all your science career. So whether you're in high school or you're in college, or you're going to be using it because you are going to have a career in science. So something very, very good to know. And it's also great if you ever want to be part of debates. This is definitely part of it. So if you're going to be a politician, then this is definitely something you want to use. So moving on, this would be the guided notes that you would be using. They're from 919 guided notes, how to write a conclusion using the claims, evidence, and reasoning model. First thing you're going to want to do is write down those learning targets that we just went through. So you would already have this open, and you would just be going through and writing these down. Whoa, it's going too fast. Okay, and then you're going to fill out this chart. So what does CER stand for? So we just went through it, so you can write claims, evidence, reasoning. Now we're going to go through what does it include. So what is kind of a summary of your claim, summary of evidence, summary of your reasoning. And then which parts of the tree represents that section and why? So why does that tree represent that section, or part of the tree represent the section? And then your last question is how the hypothesis is different from the CER. So why is a hypothesis different? Okay, so we've talked about writing lab reports. So we've talked about hypothesis. I know you guys have talked about hypothesis many, many times. So this is the very beginning of a lab report. And we're talking about the conclusion, so the end portion of the lab report. Okay, so a hypothesis. We talked a little bit. Hypothesis, you can put it in the statement if, then, because. If I do this, then I think this will happen because I know this. Okay, and usually the I know this is some scientific reason or something that's been proven before. So a hypothesis starts the investigation process. It gives you a statement of what you think is going to happen in the experiment or scenario. So this is the very beginning. We do not use the hypothesis in our conclusion. The hypothesis is what we're trying to prove or disprove. So this is our very starting thing. Before we start an experiment, we can come up with what we're going to do, how we're going to do it, and why do we think it's going to work. So that's kind of what a hypothesis is. So I have a couple examples here. Here's a very simple one. If I go upstairs, okay, so if I do this, then my dog will follow me because she's scared of being alone. Or I could have given more scientific because she has anxiety. So I guarantee you, if I went and walked up the stairs, my dog would follow me because she's scared of being alone. That is just her. So I could go and run this experiment right now, and this is what I believe would happen. Now, would it happen? More than likely. I'm 99.9999% sure it would happen, but it could be disproved, right? So if it was disproved, then I would talk about that in the conclusion. Now, example number 2. So this is more scientific. If I sit a plant in the sun for 3 hours a day, then the plant will grow 2 centimeters per day. So I wouldn't say then I think the plant will grow. No, you're making a statement of what you truly believe is going to happen. This is what's going to happen, not think. because the sunlight is sufficient enough for the process of photosynthesis to create enough glucose for the plant to grow. Okay, so you guys should have had biology and should know what this means. So I have my if, then, because. If I do this, then this is going to happen because of this process. And usually your because is a scientific reasoning, which my scientific reasoning was photosynthesis, and it creates glucose, and then the plant can grow. So let's talk about the CER. Okay, it's a conclusion. Okay, so we're writing a conclusion. This is after we've done the experiment, we've made the data, we've made the charts, we've made our observations, we've done everything. Now we're going to take it and evaluate it, and we're going to explain to somebody why we believe this, or what do I have to prove this. So the first part is the claim. Okay, this would be the very first sentence in your conclusion. And I kind of represent the claim. It's kind of the body of the tree. It's the trunk of the tree. Without the claim, we don't know where to start. There's nothing to stick to it. So we need to start with our statement. Okay, so a claim answers a question. Every lab, there's a question that goes along with it. That's the whole point. So, like in my plant example, the question could be, how many hours of sunlight does it make to have a plant grow 2 centimeters? Or how does sunlight affect the ability of a plant to grow? Okay, so we always come up with a question. So in science, when we come up with a question, that's how we want to answer it. So that's how we come up with things. How do I cure cancer? There's a question. Now it's a big question, but it is a question. And then you go through and you can do experiments to try to answer the question. So our claim is a statement about our hypothesis or the question. Okay, it's not saying my hypothesis was right, because that's not it at all. That's not what I'm saying here. It's a statement about the hypothesis. So I'm not going to say my hypothesis was right or wrong. You could state, you're really answering the question based on your evidence. And you'll see a lot more of that when we're in class. Okay, so the claim is just a statement. It's literally cut and dry. If my question was, how far can I jump? The claim would be, I can jump 6 feet. That's it. Answering the question as simply as possible. But you have to choose a side. So the side you're going to choose is whatever your evidence states. So if I went to jump and 3 times I jumped and I only jumped 5 feet, well, I wouldn't want to state a claim that says I can jump 6 feet. We would want to look at the evidence and come back to the claim and say, okay, my hypothesis was wrong of I can jump 6 feet, or I believe, I can. You're going to look at your evidence and you're going to state your claim about jumping 5 feet. Okay. So, and we're going to go to this little girl scenario in class tomorrow. But again, it goes back to the tree because it's the basis of everything. That the conclusion, it's your first statement, the first thing somebody's going to see, and the first thing that somebody's going to want to look at. Because a lot of times most people don't want to read something if it's not the opinion that they believe to begin with. So this is your statement. Okay, the evidence. Now, I keep talking about evidence and data and graphs and tables and all this kind of stuff. This is all evidence. Now, I refer to evidence as the leaves on a tree. Okay, they're all separate. Okay, leaves aren't grown together, they're attached to a stem, which is actually part of the trunk of the tree. But they're all separate. So leaves are like evidence. They're all separate pieces that we can combine together to make a tree, to make a full tree, but it takes all of them working together to support the whole tree. So one leaf isn't going to do enough photosynthesis to support the tree, but we put them all together and we've got a really good case to support the tree, to support the claim. So evidence summarizes test results or gathered data from direct observations. So each one of these leaves is a source of evidence, as we would put it. So maybe this one is a piece off a table. This piece is a piece off a graph. This is something you learned when you ran the experiment. Here's an observation you made. So there's all different sorts of pieces of evidence, and they all work together to support the claim, which is that base of the tree. When you're writing a conclusion, you always refer to the data. Okay, so data comes in many different forms, but if you are second guessing yourself, look at that data table, look at a graph, look at something like that. That gives you an immense amount of information that you can always use as data or your evidence. So refer to the charts, refer to that kind of stuff because it will be evidence. And then the reasoning. The reasoning is the roots of the tree. It's the whole beginning of the tree. Without the roots, the tree would fall over and the leaves wouldn't live. They don't have any place to send their evidence to. Okay, so the leaves, they do photosynthesis and they send those sucrose and glucose molecules down to the base of the tree to store them. That's what roots are for, is storing all that good stuff, bringing up water. So it's the reasoning. I can give a bunch of evidence, but without a reasoning, it doesn't really mean a lot. You've got to have the scientific parts to back it up. So why this is a reasonable explanation for your claim. Okay, so you're taking your evidence and you're giving a reason to it. So I can always say that I can jump 5 feet, but what's the reason why I can jump 5 feet? I can say anything I want, but I need to be able to back it up with a reason of why I'm saying it. You can go to global warming. I can say there is global warming. I have evidence that the temperature on September 19th last year was 65 degrees and September 19th this year is 69 degrees. That's a piece of evidence. It's not perfect evidence, but I would need to apply some reasoning to it. I show that between last year and this year, the temperature of this area has increased because, or the reasoning is, there was more houses built, so more concrete, which absorbs more heat. There you go. There's your reasoning. You have to have a scientific background for your reasoning or some sort of reasoning. Like I said, you can use this in debates. So you're not just going to throw out a bunch of facts without explaining what those facts mean. So that's your reasoning. So why is this a reasonable explanation for your claim? Okay, so why is it reasonable evidence for your claim? You may make inferences at this point if they're evidence-based. So just because you give a piece of reason doesn't mean that it has to be true or proven or anything like that. Think of all the stuff in space. Do we have true evidence on black holes? We have lots of evidence, but we don't really know what it means. But we can make inferences based on the evidence. So we can decide what we believe the evidence says and give our reasons for it. But it needs to make that clear connection to the evidence. So again, it's like the roots of the tree. It's what pulls it all together. It keeps it all together in one spot, doesn't allow it to fall over. If you have no reasoning, then it really, a lot of people wouldn't even look at it. It's just a bunch of numbers or observations. So the conclusion, again, it's a tree. Has the roots, which is the reasoning, trunk, which is the claim, and all those itty bitty little pieces of evidence that allow it, that support the whole thing, support the whole structure. Okay, and we'll be doing our practice tomorrow in class. So you guys have a great evening, and we will see you tomorrow.